Greg, we've said a good deal now about the Iron Curtain in Western Europe. I'm sure that our viewers would appreciate your telling us a little something about the trade problem in Japan and in Asia.
There is a problem in Japan that is as serious as that in Western Europe. Japan formerly got practically all of her coal, iron ore, manganese, a great part of her foodstuffs from Manchuria and North China. Today, Japan cannot get these materials from those sources, and the problem before the Western democracies, if they wish Japan to stay with them, is where can Japan get these materials?
Well, sir, I believe then that to simplify, this is true, isn't it? That the world is simply divided into two parts, and as long as those two curtains are there, we're going to have these terrible trade problems, aren't we?
Oh, yes.
And do you see any chance or any indication that this problem may be lessening any, that the Russians and their group may be less recalcitrant in the future?
Well, I think that the pot shouldn't call the kettle black in the restrictions, but through the Iron Curtain, I think we have been just about as severe as the Russians have.
But at any rate, our viewers can expect that this problem will remain with us for quite a while, and it's going to be a very difficult one to solve.
Oh, there's no question about that.
Well, thank you, Mr. Gregg, very much for being with us tonight, sir.
The editorial board for this edition of the Longines Chronoscope was Mr. William Bradford Huey and Mr. Kenneth Kramer. Our distinguished guest was Mr. Eugene S. Gregg of the United States Consul International Chamber of Commerce. If there's one reason, above all others, why so many people want to buy Longines watches, that reason is confidence. William Pitt once said, "Confidence is a plant of slow growth." The great confidence in the Longines watches of today matured from the excellent performance of millions of Longines watches over the past 86 years. That same performance that has won for Longines watches in open competition with the world's leading watches, 10 World's Fair grand prizes, 28 gold medals, and countless honors for accuracy from the leading government observatories, has also won for Longines the title of the world's most honored watch. The beauty, the good taste of every Longines watch is self-evident. The years have proved that any Longines watch can be purchased with confidence, that it will deliver in full measure the greater accuracy and longer life for which Longines watches are world-honored. Longines, the world's most honored watch, premier product of the Longines Whitnall Watch Company, since 1866, maker of watches of the highest character. We invite you to join us every Monday, Wednesday, and Friday evening at this same time for the Longines Chronoscope, a television journal of the important issues of the hour, broadcast on behalf of Longines, the world's most honored watch, and Whitnall, distinguished companion to the world-honored Longines. This is Frank Knight, reminding you that Longines and Whitnall watches are sold and serviced from coast to coast by more than 4,000 leading jewelers who proudly display this emblem, Agency for Longines Whitnall Watches.
You beat the clock on the CBS television network.
Here's how to help build strong bodies 8 ways.
Eat Wonder Bread. You want to grow bigger and stronger, don't you?
Golly, sure.
Okay. A sandwich daily and 2 slices of Wonder Bread every meal give you 8 elements you need. As much muscle-building protein as roast beef, as much calcium for bones and teeth as cottage cheese, as much phosphorus for cell metabolism as this egg, as much iron for red blood as 3 lamb chops, as much vitamin B1 for appetite as fried liver, as much vitamin B2 for growth as this much cheese, as much niacin for mental health as 6 sardines, as much energy as 2 glasses of milk. That's why you can help yourself grow bigger and stronger 8 ways with Wonder Bread. I mean grow bigger and stronger 8 ways.
So be sure to eat Wonder Bread.
Get Wonder Bread fresh at your grocer's today.
Ya, con él bebiendo el vaso de agua en el espejo, luego entra otro tipo, luego recuperamos, vemos la sala de espera, está ese profesional que decís vosotros, y por medio de él nos vamos enterando de que él está teniendo los síntomas exactos que le está diciendo, que es asombroso, ¿no? Y luego, qué sencillez y qué limpieza con el médico. El médico aquí, la otra enfermera que la tiene al fondo, cuando le va diciendo, no se preocupe, tome las mismas. Dices, por favor.
Le va diciendo lo que más se teme, que puede tomar cualquier cosa.
Exacto, pero que casi hay un paralelismo entre ese médico, digamos, es un cierto paralelismo con la propia oficina suya, vamos, o sea, que es, se lo quitan de en medio. Hay un intento, no sé si de la enfermera, de otro médico que ve la radiografía aquella y se queda mirándolo y demás y piensa que a lo mejor
hay otro médico
se
que
debería
sigue
decir
mirando
algo,
esa alarmante radiografía en la que sin entender nada tú ahí ves una mancha grande que...
Bueno, el joven que luego habla con el médico, ¿no? Y la enfermera que interviene diciendo que habría que echar mano del veneno en una situación así.
Es curioso porque yo no sé si es un problema mío, de cada uno vemos las fotografías distintas, ¿no? De los blanco y negro, pero el principio y el final de la película tiene un tono que es la placa y esa especie de contraluz al anochecer cuando se va alejando la figura, parece igual, parece como una radiografía del parque cuando ya está tirando contra el cielo, que es una maravilla. Y en esta película hay uno de los iconos mejores y más claros de la historia del cine, que es el sombrero. Ese sombrero es uno de los iconos
llamativo
más claros para la historia del cine, va a decir una referencia de un sombrero, porque tiene una presencia enorme ese sombrero, y sobre todo la rescatas en esa parte del final cuando...
Con esos comentarios que hay sobre él, porque ahora estás viendo la visión que ha dado desde fuera. Es que es una película que te ofrece continuamente la visión desde dentro, pero sin ningún comentario interior. O sea, no está exteriorizado por el personaje, ni por su actuación, ni por lo que él dice, y luego la ves desde fuera por el efecto que hace externo, que es lo que hace que la película tenga una especie de riqueza increíble, constante, que está pasando de la visión externa a la interna constantemente, que es como, por ejemplo, es muy hábil, y eso también lo comentabas tú antes. La película al principio es como totalmente externa al personaje, que te lo describe como un funcionario más que está...
It's on, so if you say anything that you happen to regret, just tell me and I'll take it out.
Good deal. Good deal.
But, so just say my name is and state
My name is Jeff Walsh.
You guys are?
Excellent. Thank you. Thank you very much. Part of the meaning of life is damn good food.
Valley Lopez.
Hey, my name is Bob Woodkey.
Courtney Smith.
My name is Glenn Muschin.
My name's Janelle.
Hi, I'm Johanna Cruz.
And I'm Leslie.
And according to you, you guys can take turns or whatever. What is the meaning of life?
Okay, the meaning of life for me is enjoying nature and like looking at like how things are, like the trees and the grass, the water, everything. There's a meaning to it, and I think it's like very, very interesting. It's really cool too, because like without electricity and cell phones and everything like that, it's like, I don't know, it's not how nature or like life, you know. So I don't know, it's kind of cool, I think.
A story about my dad that is pretty awesome. I grew up in a really big family, and we didn't have a lot of money, but we had a lot of fun. We had parents that were extremely, I had parents that were extremely creative. Both my parents are dead now. My dad was a musician, and he could create music out of nothing. And I think that that was like a parable or a wonderful gift that he gave to us. There was a time I was about, I was probably about 18 or 19 years old, and I don't know if my father was retired by then or slowing down quite a bit. He was quite a few years older than my mother, so I always kind of remember him as an older man. And it was raining. It was probably, I don't know, maybe a heavy, heavy spring rain. And my father had set out pie plates and empty tin cans and empty everything all along the eaves of the house. And as the drips came and hit these little containers, he moved everything around so it created like the most wonderful little symphony out of the raindrops. And it was, you know, in retrospect, one of the most beautiful things, I think, that I can remember from my childhood. I'm going to get all teary. Because, wow. Because it's all around us. The beauty, the sky, the trees, the grasses, and those are the things that make my life full. And I'm very blessed that I had parents that said, go outside, enjoy it, do, make, or lie down and just soak it in. They really provided us or encouraged us in that way.
The symbols of atomic energy are becoming increasingly familiar to all of us in this age of the atom. Inventions pertaining to atomic radiation, like the nuclear reactor these technicians are working with, are bringing scientific achievements undreamed of a few decades past. Particularly promising are the advances being made in the biological sciences through the application of the atomic elements made radioactive artificially in the nuclear reactor are frequently used as sources of such radiations. In the metal cylinder coming out of this nuclear reactor is one of these elements which has been bombarded and now contains a radioactive isotope. Such radioactive isotopes are among the newest tools to be applied to problems in biological research. Sometimes the scientist wishes to observe the effects of the radiations themselves. Alpha particles, beta particles, gamma rays and neutrons are some of the most familiar kinds of radiation. Gamma rays are particularly useful in the study of living things. Gamma rays, like other kinds of radioactive energy, affect living cells. If the effect is serious enough, the entire organism becomes ill and is stunted or dies like the plants nearest the source of gamma rays emanating from radiocobalt located inside this pole. Most radiation experiments, like the one going on here, do not destroy the living thing being tested. For example, geneticists apply gamma rays to living cells to discover the effects of radiation on growth and heredity. In one kind of experiment, one-celled forms of life are used. Here, a one-celled form of life is reproducing by simple division. Some forms multiply by sexual reproduction. Does radiation affect the rate at which such cells reproduce? In a typical experiment, the geneticist seeks the answer. He transfers a culture solution into a radiation chamber. This culture solution provides a favorable medium in which paramecia, a kind of one-celled animals, live while being subjected to gamma rays. Next, the living paramecia are placed in the culture solution. They may be irradiated in a lead safe like this. Inside is a source of radioactive cobalt that releases gamma rays. After irradiation, the paramecia are carefully observed under the microscope so that the number of cell divisions can be counted. The geneticist finds that the irradiated cells do reproduce faster than cells that have not been irradiated. Future generations of paramecia will also be studied to see if the effects of radiation are transmitted from one generation to the next. Experiments using radioactive elements are being applied to larger forms of life as well as to single-celled forms of life. Here, corn plants are the subjects of experimental work. Gamma rays, released by the radioisotope cobalt, located within the hollow pole, are affecting cells of the corn pollen. Experiments are also conducted in special indoor plant growth rooms like this one, where they can be controlled even more closely than is possible in the field. The plants in this growth chamber are being subjected to gamma rays released from a radioactive element inside the lead container. The problem is to discover how this atomic radiation may affect the hereditary characteristics of living things. That is, how do radiations affect the tiny units of cells called genes that transmit hereditary characteristics? The genes are represented here as bead-like bodies attached together in chains. Every living thing inherits its characteristics from the genes of the parent cells that have gone before and passes on similar characteristics to its descendants. Atomic radiation interferes with the normal process by breaking apart the chromosomes which carry the inheritance genes. In this way, radiation affects inheritance. Chromosomes like these from corn are large enough to see under the microscope. Here, there are some detached fragments of chromosomes, particularly at the upper right, proving that the atomic bombardment they have undergone has caused some of them to break apart. The exact results of such changes on future generations can be discovered through growth experiments. The results may be beneficial. Already a strain of corn that is especially resistant to fungus disease has been produced through irradiation studies in which radiations have affected the parent plant cells. Scientists use radioisotopes in another entirely different kind of experiment, the tracer study. In this kind, they try to avoid any effects of the radiations themselves. For example, in this experiment, plants called algae are being given radioactive carbon dioxide in order to study the food-making process carried on by their cells. Here is another research project in which radioactive carbon dioxide is used. The plants in this special greenhouse live in an atmosphere rich in radioactive carbon dioxide. Radioactive carbon dioxide is piped into the greenhouse. One objective is to produce quantities of radioactive plant products such as drugs, which can be used in experiments that may lead to improved techniques of diagnosing and treating some human diseases. Animals as well as plants may be the subjects of research using atomic radiation. Studies in nutrition often depend on the use of rats. Here, the experimenter uses a rat that has been fed radioactive table sugar. The experimenter places the rat in a special container where all of its waste products can be collected for analysis. By knowing how much radioactive sugar was fed and how much radioactive waste is given off, the physiologist may discover more facts about the chemical processes that take place when a carbohydrate is digested and used. Similar experiments may be performed to study the use of proteins, fats, or other types of food. The distribution of an element in an animal's body can also be tested using rats. In a typical experiment, blood is taken from a rat previously injected with radioactive iron. The blood will be tested for radioactivity to find how much of the radio iron is still present. To do this, the iron is removed from the blood sample and electroplated onto a small metal ring called a planchet. The amount of radio iron that electroplates out on the planchet can be exactly determined by using radiation counting equipment. Based on such experiments, the dosages and techniques of using radio iron for treating disease may be perfected. Much of the research in biology is done in the hope of contributing to the welfare of humans. This is particularly true in the study of diseases like cancer. Learning to control a disease depends in part upon understanding the processes by which the disease develops. In cancer, animal experimentation is especially helpful. Experiments are planned to study how cancer develops. To do this, cancer may artificially be induced in animals through excessive exposure to radioactivity. Here, beads containing a radioactive isotope are strapped to the rat's body. The radiations released cause the rat to develop cancer. Other experiments are devised to study techniques of treating cancer. One technique employs the cyclotron, a machine that can produce a stream of extremely fast-moving atomic particles. In this case, a beam of radiations called deuterons is used. The treatment is given in a specially shielded room called a deuteron cave. The treatment depends upon focusing a narrow pencil-like stream of deuteron particles on the tumor. From time to time, the rat is turned so that the tumor is affected from different directions. The tumor receives a much larger amount of radiation than any of the surrounding tissue. In this way, the effects of radiations can be beneficial to the organism as a whole. Experiments of this type seem promising, but such treatments are not applied to humans until they have been thoroughly tested on animals. Radiobiologists use sources of radioactivity for internal human use as well as external use. Here, a liquid containing a radioactive isotope is being prepared for human use. Radioactive atoms in the solution will attack the cancer from within the body. Safeguards are continually being perfected to avoid damaging the healthy tissues of patients or those administering the treatment. Since atomic radiation improperly used may be extremely dangerous, much research has been done to discover the most effective protective measures. In league with physical scientists, biologists are learning how best to protect humans from dangerous amounts of radiation. Protective clothing, barriers made of radiation-resistant materials, remote control equipment, and medical tests are some of the measures developed through experimentation to guard against harmful exposure. From their raw material stage, through their use, to the ultimate disposal of any waste that remain, radioactive materials are handled according to techniques prescribed as the result of painstaking biological research. The future applications of atomic radiation can scarcely be imagined, but progress is being made and research is leading the way. And in this research, the biological sciences continue to take their place in the ongoing pattern of achievement by advancing man's understanding of life itself.
drank it so fast.
I can't say that I blame her, though, Mother. Orange juice is so good, and so good for her.
Yes, but it's so expensive.
Not when you use Snowcrop frozen fresh orange juice. Why, thank you, Teddy Snowcrop. A day-by-day study for 1 solid year proved Snowcrop cost you only half as much. Yes, only half as much as the same amount of juice from oranges you have to carry home and squeeze.
Is that so?
It certainly is. And what's more, Snowcrop gives you all the fresh flavor, vitamin C, and health-giving minerals of home squeeze juice. And it's so easy to prepare. Just take a look at this. To 1 can of Snowcrop orange juice concentrate, add 3 parts water, mix, and serve. And in a recent nationwide blind taste test, people voted by over 2 to 1. Snowcrop tastes better than home squeeze. There, children, try some. Now, what do you say?
Oh, boy. That's good.
It's always good. So get Snowcrop frozen orange juice at your favorite food store.
The finest foods are chosen.
Yeah, all the freshest foods are frozen by Snowcrop Frozen Foods. Get Snowcrop. Snowcrop.
And remember, your grocer is now featuring Snowcrop's Garden Fresh Values. Snowcrop frozen peas, broccoli, spinach, orange juice, and Snowcrop frozen strawberries.
Tanikawa Shuntaro, Ikiru. 生きているということ、今生きているということ、それは喉が渇くということ、木漏れ日が眩しいということ、ふっとあるメロディーを思い出すということ、くしゃみすること、あなたと手をつなぐこと、生きているということ、今生きているということ、それはミニスカート、それはプラネタリウム、それはヨハン・シュトラウス、それはピカソ、それはアルプス、すべての美しいものに出会うということ、そして隠された悪を注意深く拒むこと、生きているということ、今生きているということ、泣けるということ、笑えるということ、怒れるということ、自由ということ、生きているということ、今生きているということ、今遠くで犬が吠えるということ、今地球が回っているということ、今どこかで産声が上がるということ、今どこかで兵士が傷つくということ、今ブランコが揺れているということ、今が過ぎてゆくこと、生きているということ、今生きているということ、鳥は羽ばたくということ、海は轟くということ、カタツムリは這うということ、人は愛するということ、あなたの手のぬくみ、命っていうこと。